In pursuit of transferring technical knowledge and just to gear up the new engineering entrant, myself Pranav is here to deliver today's presentation, Power Transformer Part 66. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Now let's start with non-heterocyclic nitrogen compound in the crude oil. We have already seen that in this molecular structure, nitrogen molecule is not incorporated into a ring, that is in figure 188. It is rather to be found that along with the heterocyclic nitrogen in crude oil, there may have some evidence of containing low concentrations of primary amines, that is R-NH2. Moreover, during crude oil refining activities through hydroprocessing technology, there would have some conversion of non-basic nitrogen compounds into strong bases, that is derivatives of cyclic amines. Hydroprocessing technology is subjected to condition where would have to add hydrogen under the high pressure and temperature for the desired purpose of eradicating the impurities like sulfur, oxygen, nitrogen, and metals from crude oil. Hydroprocessing technology is thus to be applied where the oil is first to be heated in a furnace and then combined with hydrogen would pass through a reactor loaded with a suitable metal oxide catalyst such as cobalt and molybdenum oxides or alumina. This process, which also termed as hydrocracking, would be the most useful practice of removing many of the contaminants as hereunder. 1. Through the hydrogenation reaction, where two hydrogen combines with sulfur, making to form hydrogen sulfide, that is H2S. Nitrogen compound are converted to ammonia, rather NH3. Number 3, organic or inorganic metals contained in oil are to be deposited on the catalytic bed. Number 4, some of the olefins, aromatics or naphthenes, which would then to be saturated with hydrogen to become paraffins. And number 5, thermal and catalytic cracking of crude oil would also have been taken place under controlled high pressure and temperature, and by which heavy hydrocarbon molecules that are to be broken up into lighter molecules, causing to create some gases as methane, that is CH4, ethane C2H6, propane C3H8, propylene C3H6, butane C4H10, and butylene or butane C4H8. If the sulfur content is found to be high, then for maximum removal of sulfur, it requires to carry out the process with higher temperatures and pressures. Indeed, it can be concluded that the most serious contaminants in crude oil would have been the basic nitrogen compounds. Crude oils, as extracted from under the ground or under the oceans, are really of little use in their raw state, but their actual value lies in the product as created from them. It is also to be worth mentioned that the composition as well as content of impurities in crude oil would have to vary from oil field to oil field. In the refinery, where an organized and coordinated arrangement of manufacturing processes would therefore be designed to produce physical and chemical changes in crude oil to convert it into useful products like transformer oil, lubricating oil, fuel oil, bitumen, etc. There is rather to be recommended that the crude oils containing nitrogen compounds greater than 0.25 weight percentage must need to have a nitrogen removal treatment in refineries. 0.25 weight percentage. If it is greater than 0.25 weight percentage, then it must need to have a nitrogen removal treatment in refineries. In ASTM D5762 standard that has provided the analytical techniques for the detection and determination of organically bound nitrogen compounds present in crude oil fractions. However, all the discussions are confined regarding organically bound nitrogen compounds present in crude oil fractions. There would also have been exhibited abundant amount of inorganic nitrogen ammonium ion present in crude oils, and it is to be noted that all nitrogen containing compounds, organic and inorganic, would have the potential participants in acid-base interactions. Total acid number, that is tan value. The acidity of crude oils can be distinguished by their respective acid number or tan value. A measurement of acidity or tan value is one of the most indicative quality measurement of crude oil, which can be determined by the amount of potassium hydroxide KOH in milligrams that is needed to neutralize total acids in 1 gram of oil. To meet the gap between extensive demand and consumption, there would have been a present trend of exploring and utilizing the heavy as well as inferior type of crude oil, that is high acidic crude oil. Tan value must have to indicate the actual concentration of acidic compounds in oil, and at the same time crude oil corrosiveness that would have been influenced mainly due to the presence of sulfur and acid components in crude oil. The quality of crude oils is therefore better to judge with their elevated sulfur content and quantum of acidity. Acidity in crude oil can be classified by the underneath tan value. Tan value less than 0.5 KOH per gram or just 0.5 milligram KOH per gram, then considered as conventional crude oil. From 0.5 to 1 milligram KOH per gram, considered as acidic crude oil, and greater than 1 milligram KOH per gram, considered as high acidity crude oil. Usually, high acidity crude oil has the following characteristics. 1. High acid value, lesser content of light components, high density and viscosity, high gel asphalt content, gel asphalt content, high salts and heavy metals content, highly corrosive in nature. The acidic components in crude oil that include naphthenic acid, fatty acid, aromatic acid, phenol, thiol, etc. are usually called as petroleum acids. Though the content of petroleum acids in crude oil would have been significantly low in percentage weight, but still those acids may have to induce serious phenomenon of corrosive effects. Naphthenic acids that would occur naturally in crude oils and their presence among those petroleum acids would usually be of the order more than 85%. Again, I repeat, naphthenic acids that would occur naturally in crude oils and their presence among those petroleum acids would usually be of the order more than 85%. Naphthenic acids that would rather be mixture of cyclic, aromatic and linear monocarboxylic acids, which thus to present in crude oil as a potentially corrosive element. The acidity as well as to evaluate the corrosive properties of crude oil would therefore to be reflected only by the total acid number measurement, which should be carried out prior to start the refining processes. In AASTM D664, where it has provided a standardized working procedure to determine the sum of all acid compounds present in crude oil samples by an acid-base potentiometric titration method using KOH, that is potassium hydroxide, as titrant. Key parameters to evaluate quality of transformer oil. Selection of transformer oil is therefore to be determined based on the special characteristics of insulation for transformer as well as to fulfill the additional task as heat transfer and cooling. So, the oil must have the properties which include a high voltage dielectric strength, high dielectric constant, low power factor, high chemical stability, low viscosity, low pour point, low volatility, high thermal conductivity, aniline point. Oil always have to offer neutral behavior with all sorts of insulating materials as well as internal system components. The high performing transformer oil must have non-corrosive in nature with very low sulfur level. Presence of significant level of corrosive sulfur compounds in the oil may lead to react with the system components such as transformer coils, that is copper, causing electrical and thermal damage. Exhibiting the complexity and extent of the problem, it has been recommended that the transformer oil should have to satisfy the oil or copper interactions tests as prescribed in ASTM D1275B. Viscosity is one of the most important quality of liquid oil which can play an essential role to refer the oil resistance to the flow. It is rather to understand that lower be the viscosity, the higher will be the circulation speed of the oil, which equates in a higher quantity of heat being dissipated. It is standards in the standards IEC 60296 and ASTM 3487, where they have precisely recommended an upper limit for viscosity of insulating oils, which is 12 mm square per second at 40 degrees centigrade. 12 millimeter square per second at 40 degrees centigrade. Flash point is one of the most important criteria for selection of transformer oil, as it indicates the lowest temperature at which a liquid gives off vapor to form an ignitable mixture in air near the surface of the liquid. Therefore, the liquid flash point is the lowest temperature that can cause a fire. So, the lower be the flash point, the greater will be the risk of fire. For good mineral based transformer oil should have the flash point as high as 140 degrees centigrade. However, the flash point of a flammable liquid would also have to vary with its concentration. Also, there is an exponential relationship between the temperature as well as concentration and viscosity of the liquid. That is, viscosity of the liquid oil. Viscosity of high performing unused transformer oils are normally in the range of 7 to 8 millimeters square per second at 40 degrees centigrade. And according to the standards, even with such low viscosity, their flash point must never be lower than 135 degrees centigrade. The mode of application as well as environmental conditions both are the most vital deciding factor to select the type of transformer oil to be used, whether naphthenic based transformer oil or paraffinic based transformer oil. Paraffinic based transformer oil, whose pour point, though it is being comparatively higher, but it is the most preferred choice to use in hot environmental conditions, as it is cheaper than that of the naphthenic based oil. Naphthenic based transformer oil, as it is more or less wax free, so it has a good flowing feature under low temperature in cold climatic conditions. Solvency is thus to refer the ability or potentiality of a base oil to dissolve another chemical species at the molecular level, which may be of an additive component or a contaminant such as water or an oxidative product, that is sludge, as produced. The aniline point is most often used for characterization of the hydrocarbon based oils by estimating the percentage rate of solvency of aromatic hydrocarbon content in the base oil. That is why aniline point is most important. ASTM D611-2023 has to provide the standard test method for quantifying the base oil solvency as well as measuring the aniline point and mixed aniline point of petroleum products and hydrocarbon solvents. It is quite evident that the aromatic hydrocarbons would exhibit the lowest values of the aniline point, whereas the paraffin based be of the highest value. The oxidation rate is another important parameter to consider during the selection of the transformer oil. In case of naphthenic based transformer oil, which is easier to oxidize, and the oxidation rate is much higher than that of paraffinic based oil. But as the aniline point of naphthenic based transformer oil is much lower than that of paraffinic based oil, so the naphthenic based oil has the property of high solvency. Basic importance of determining the aniline point of oil. Aniline point or aniline point temperature rather can be referred as the minimum temperature at which the solubility of aniline in oil or oil in aniline reaches 50 volume percentage. In other way, to express the characteristics of aniline point of the oil is thus to refer as the lowest temperature at which the equal volume of aniline and oil are completely in miscible state. Aniline is an aromatic compound which of the formula C6H5NH2, aniline point of an oil would have to indicate a rough estimation of the relative content of aromatic compounds that are to be present in the oil. From the analysis, it has been concluded that the oil with having higher aromatic content would have a lower aniline point and vice versa. Aniline point is also to justify as a measure of oil solubility where the lower be the aniline point of an oil, the higher be its solubility criteria relative to aromatic compound and vice versa. Hydrocarbon based oils of different category would have the separate aromacity, which because of their difference in aniline points, causing a sharp contrast on their respective ability towards solvency or reactivity characteristics. Naphthenic crude oil reserves as account for only 2 to 3% of global crude oil reserves. So, there would have high strategic significance in production of low flashpoint transformer oil and aviation fuel. Normal naphthenic crude oil that would have contained more than 50% of saturated hydrocarbons along with more than 40% of naphthalene content. As the naphthenic based oils contain mainly of naphthenic, that is be higher than paraffin contents and aromatic hydrocarbons, so their aniline points would also lie in between the values of paraffins and aromatics. However, it is to be noted that the aniline point is being a property that indicates the solubility of a base oil. According to the definition, aniline point is thus to refer as the lowest temperature at which the base oil is completely miscible with an equal volume of aniline, that is C6H5NH2. The paraffinic base oil would have the aniline point that may approximately be of 100 degrees centigrade or greater, whereas naphthenic or aromatic base oils have a low aniline point, that is less than 100 degrees centigrade. So, they have the better solubility than that of the paraffinic base oil. It is categorically to be noted that the viscous fractions of the base oil composition and solubility would somehow be characterized by its viscosity gravity constant. However, viscous fractions of base composition would thereby be the combination of its specific gravity and kinematic velocity. The specific gravity or relative gravity is a dimensionless quantity which thus to be rather defined as the ratio of the density of the base oil to the density of the water at a specified temperature. Basically, kinematic viscosity of oil must have a direct relations with its specific gravity, and that would have been indicated by its resistance to flow and shear stress due to gravity. According to ASTM D2501, the viscosity gravity constant would have been calculated from the determination of specific gravity at 15.56 degrees centigrade, that is 60 degree Fahrenheit, and from kinematic viscosity at 37.78 degrees centigrade, that is 100 degree Fahrenheit, of the oil. Conclusive part. High paraffinic hydrocarbon based oils have higher aniline points, which thus to indicate low levels of aromacity and are supposed to have the poor solvency or reactivity characteristics. In contrast to paraffinic based oils, naphthenic based oils are being distinguished by their lower value of aniline points and would thus to behave differently than paraffinic oils. Naphthenic based oils must have a higher solvency or reactivity characteristics with lower pore points. Naphthenic based oils, though, would have to contain a lower quantities of linear paraffins, that is N paraffins, which thus to be, but still the oxidizing product, that is formation of sludge as formed in the oil, would comparatively be much more in soluble state, causing a less interference on the equipment cooling cycle. Again, I repeat, naphthenic based oils, though, would have to contain a lower quantities of linear paraffins, that is N paraffins, but still the oxidizing product, that is sludge, as formed within the oil, would comparatively be much more in soluble state, causing a less interference on the equipment cooling cycle. Actually, viscosity gravity constant may refer to be an useful function for framing out an approximate characterization of the viscous fractions as prevailed within the hydrocarbon based oil. Viscosity gravity constant is a dimensionless number and that lies between 0.8 to 1. If the value closes to 0.8, which would confirm that the oil is of paraffinic in characteristics, that is paraffinic in character rather, while value closest to 1, which indicates that the base oil has a higher aromatic content. Let's stop here. Further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would rather encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.